Hello students, we are in the chapter 1. Chapter is set. We will take a new topic today. Okay, let us discuss. Here, let us take some pictures. Pictures of some players and pictures of some sports or games. At first we have taken Virat Kohli, then Messi, then Sania Mirza, then Hima Das. And in that side, there are some sports or games. Now how we'll relate them? Virat Kohli is related to cricket. Messi is related to football. Sania Mirza is related to lawn tennis. And our Hima Das is related to athletics. Okay. Now how they are related? We say that they are the players of those games or sports. Likewise, let us remove this. Likewise, in our mathematics also, we can set some relation between numbers or among the numbers. Now, let us see how the numbers are related. Okay, let us take two set for that. We have taken two set A and set B. Okay, now here let us consider some elements. Suppose 1 and 3. There we consider some elements 2, 4, 6. We already learned the Cartesian product of two sets. Let us find this at first. A cross B. 1, 2. 1 will be paired with 1, 2, 1, 4, 1, 6. তারপর 3 হল 3, 2, 3, 4, 3, 6. Let us do that. 1, 2. Get the Cartesian product. Now, some of you may find they are related in some manner. We want to discuss that how they are related. This is our today's topic. That is relation between two sets. Suppose set A to set B. What is that? We want to discuss that. Here, suppose the element of set A is represented by this symbol X and the element of set B be related by the symbol Y. That means in our language we say X belongs to set A and Y belongs to set B. If someone finds there is relation between some elements, they are related. How they are related? Someone said the elements of set B, some elements of set B are related with some elements of set A in such a manner that some elements are double of the element of the first set. This is just an example. There are so many examples, infinite example. Okay, for the sake of simplicity we have taken such an easy example. Now, if this is so, that means these elements are double of this. If this is so, how they are related? Okay, let us take 1 is related with 2. How? 2 is double of 1. Then there is a relation between 3 and 6 because 6 is double of 3. 4 is not related here in this relation, in this regard, in this manner. Okay, so if we want to make a pair of this and we want to make the set also of this pair, 1 is related to 2, 3 is related to 6. Now let us see, are these elements are also present in A cross B? Let us see. 1, 2 is present here. 3, 6 is also present there. What does it mean? This is a subset of this. Okay, as we are saying about relation, let us represent it by the symbol R. So we can write that here R is a subset of the Cartesian product A cross B, and we already learnt about the power set. If someone said we have to make the subset of this. So how will write? At first we shall start with always 5, then 1 2. So here how many subsets are there? Let us see. 1 2 3 4. 4 subset. How 4 subset? Already we learned that this is 2 to the power number of subset. 2 to the power how many elements are there? 2. So in this relation there are 4 subsets. That means 4 relations are there. This is also a relation. 2 is the double of 1. 6 is double of 3. Okay, they are the double of each other. So there are 4 relations here. 1 2 3 4. If we know the relation here, how many elements are there? Okay, there are 2 elements. So number of relations will be 2 square. Now let us take one more example to make it more clear. Okay. Now dear students, let us take one more example. Let us take 2 sets again. This is set A, this is set B. Okay, the elements are, suppose 1 2 3 4. 1 4 6 9. Again let us find the Cartesian product. 1 will be related with 4 of this. Let us make the order pair. 1 with 1, 1 4. Okay, we have found the A cross B. Here number of elements in this Cartesian product is 4 into 4, 16. You will find there are 16 elements. Now again we want to find the linkage between them, relation, how they are related. Someone said, if we again denote it the elements by x and the elements of this by y. Okay, someone said some elements are square of this. In this way, in this regard, they are related. So let us find those pair. 1 is related with 1 because this 1 is a square of 1. That is correct. 1 is related with 1. This 4 is related to 2. Okay, because 4 is the square of 2. Then this 3 is related to 9 because 9 is square of 3. ठीक है से 3 arrow 9. I test how these elements are present or not there in A cross B. 1 1 it is present. 2 4 2 4. 3 9 3 9 is there. So what is our observation again? This is a subset of this, and there is a relation between this first component and second component, first component and second component, first component and second component. How they are related? Second component is the square of the first, second component is the square of the first component, second component is the square of the first component. This is the relation. Okay, intentionally we have taken this example because always there is a gap, whether gap among the students, there are some element which can be left here also, they are here also, means that these are not related. It is not there that it is not essential that all the elements will be related. It is not like that. Some part will be related of set A with the some part of set B. We have to understand that. बुझी पाइसा ने? So in this discussion we understood that R is a subset of A cross B. A relation to ami kenaka likhu. If R is a relation from A to B, enaka likhu. Or we say that if this element X, this element X element is related with this element X R Y, we say that in such a way. That means X, how we read this? X is related to Y. X is related to Y. In this way we read it. Now in set builder method, how can we write down this? Let us see. This relation XY, that is this X component and Y component, that order pair we have taken, such that what is the relation? X is related to Y. How they are related? X belong to the set A and y belong to set B. This is so simple. X to first component first set of hoboi, second component to second set of hoboi. Okay, there is a relation. We have to follow the order pair. That means there is a relation between the first component and second component. Okay, আমি যেটো থাকি গল এটো না চাওঁ কি রিলেটেড আছে এবিলাক লৈ রিলেশন হ'ব তো ইয়াত গম পালো যে রিলেশন ইজ এ সাবসেট অফ the Cartesian product. That is the most important part. Okay, so dear student, we have seen in the last example that there is a relation between this component 1 1 2 4 3 9. So the relation was 1 1 2 4 3 9. Okay, এই ordered pair of আমি এটা বেলেগ একটা ডেফিনেশন এতিয়া চাব বিচাৰিছো the ordered pair first component কেইটা that is 1 2 3 first component. These are the first component and let us take the second component also. Second component কি হ'ব 1 4 9. Now we have given some particular name of the first component and the second component of this relation. The name is that this is known as domain. In this way we represent D within bracket R, that is relation. This is domain. Okay, ইয়াত দেখা সব এলিমেন্ট কেটা ডোমেইন নহয় those elements which are related যেটো relation আছে those elements are only domain. This 4 is not a domain. Okay, 1 2 3 this set is a domain, that is there. আৰু ইয়াৰ কি নাম দিছো এটো রেঞ্জ নাম দিছো. Okay, R, capital R. Okay, this is domain and this is range. আৰু এটা বস্তু আছে ইয়াত দেখা এই 1 4 আৰু 9 একেটা সেকেন্ড component, that's why they are range. This part is domain and this is range. আৰু এটা কিবা থাকি গল 6 ইয়াৰ এটা স্পেসিফিক নাম দিয়া হৈছে গোটেই সেট বি টুক কোডোমেইন কোৱা হৈছে কোডোমেইন গোটেই সেট বি টু এটো পার্টিকুলারলি একো নাম দিয়া হোৱা নাই কিন্তু ইয়াৰ এটা পার্টিকুলার নাম আছে that is called codomain. Okay, so we have understood about domain, range and codomain. Now here কিছুমান অলপ property কিছুমান চাওনি. Here you can see that this element 1 2 3 are there and here in set A, that means in domain the elements are 1 2 3 and in the set A the elements are 1 2 3 4. Obviously this is a subset of this. Okay, this is so domain is a subset of set A, that is the first set. Now let us discuss about this. Here you can see 1 4 9 1 4 9 and apart from this 6 is also there. That means range is a subset of set B. So আমি কি গম পালো domain is a subset of set A, range is a subset of set B. তার পাছত আমি domain কেনেকা represent করে চাও if R is a relation from A to B then domain of this relation how can you represent domain কেটা হয় first component. Okay, আমি যদি xy একটা component লিখো xy component xy আমি যদি order pair করো okay where there is a relation this first component will be always domain and the second component will be always the range. So আমি যেতে domain represent করিম okay domain denote করিম always will take the first one and for range will take the second component. So domain যেতে লিখিম আমি ইয়াত লিখিম x such that x y belong to R and this element first element belong to set A and second element যেটো আছে that belongs to set B. Okay, তার পাছত আমি এই রেঞ্জটো কেনেকৈ ৰিপ্ৰেজেন্ট কৰিব পাৰো দেখা আর রেঞ্জ যেতিয়া কম আমি কোনটো কম সেকেন্ড কম্পোনেন্ট তো সেকেন্ড কম্পোনেন্টটো লিখিম y such that same বস্তু লিখিম আকৌ xy belongs to that is this component, so this ordered pair belongs to R x belongs to A and the element y belongs to set B. Now, okay, my beloved students, we have taken another topic to discuss, and please listen carefully. Here we have taken null relation and universal relation. At first, let us discuss about null relation. বস্তুটো একদম easy. এটা set লওঁ, suppose set A. Okay, elements are 1, 2, 3. আৰু এটা set B লওঁ, 4, 5, 6. And মই ক'লো যে all the elements of set A is greater than set Y. Then we have to frame a relation. This condition I have given. ঠিক আছে, এইটো আমি ললো যে all the components of set A are greater than all the components of set B. Let us see whether this is true or not. 1, আমি যদি compare কৰো 1, 4, এটা নহয়, 1 is smaller, 1 is not greater than this, 1 is not greater than 5, 1 is not greater than 6. Again, 2 is not greater than 4, 2 is not greater than 5, 2 is not greater than 6, 3 is not greater than 4, 3 is not greater than 5, 3 is also not greater than 6. So we cannot frame a relation. There is no relation. That's why it is called null relation. Phi, that relation is null relation. R is equal to phi. ঠিক আছে, okay, this is about null relation. Null relation. ঠিক আছে, এতিয়া second বস্তুটো universal relation. আমি আকলো set to same in 1, 2, 3, these are the elements. B 4, 5, 6 লৈছো. First কি কৰো, এতিয়া আগৰ নিচিনা start কৰো. At first let us find the Cartesian product. ঠিক আছে, we want to see something, we want to do one experiment. 1 এর লগত সবর হবো 1, 4, 1, 5, 1, 6. Let us make the order pair. So there are 9 elements here, 1, 2, 3, 4, 5, 6, 7, 8, 9, because 3 3 is 9. Now I have given a condition that all the elements of set A is smaller than all the elements of set B. Let us see whether this is true or not. If some parts are true, then also let us try to write down those elements. Ete ki sa 1 4th ke horu, 1 is smaller than 5, 1 is smaller than 6. So let us do the part of 1 at first. 1, 4, 1, 5, 1, 6. Okay, ঠিক আছে, তার পাছত 2 এর লগত 2 is smaller than 4, 2 is smaller than 5, 2 is smaller than 6. Let us write it. তার পাছত 2 হয়ে গেল 3 সাম, 3 is smaller than 4, 3 is smaller than 5, 3 is smaller than 6. So let us write. Okay, now if we make a set this, here all the first component is smaller than second component, so this is a relation. Now if you look these two results carefully, you will find that they are exactly same, equal. Okay, so if A cross B is equal to this, if exactly they match with each other, then we say this relation is universal relation. Okay. Now dear student, we have taken another topic to discuss. It is inverse relation. Now let us take a relation R such that it is related from A to B, set A to set B. আমি যদি এটা অর্ডারটো চেঞ্জ কৰো, সাপোজ এনেকা আমি ভাবো যে এইটো ৰাস্তাত মানুহে গৈ আছে, মানুহটো উল্টা আহিব পাৰে. If we take in that way, B is related to A. Okay, that relation suppose represented by S. So here আমি যদি উল্টা গৈ আছো এতিয়া, ঠিক আছে, এটা রিলেশন লৈছো সাপোজ 1A 2B 3C. just this is just an example. এতে যদি উল্টাকে লিখো A1 B2 C3, we say that this is the inverse relation of this. This is denoted by R inverse. Okay, here we have denoted it by S, by the symbol S. Okay, now let us represent in set again. This is set A, set B. Okay, suppose A and B. This is the elements of set A are 1, 2, 3. Suppose they are related. We are taking only these elements. If there are other elements, we are not bothered about that. And in set B, the elements are A, B, C. A, B, C. They are related. Okay, so what are the domains here? These are domains and these are the range. Domain, as you know, domain is denoted by dr, and here range is denoted by r of this relation. What is the relation? This is the relation. আমি যদি এটা এটো রিভার্স কৰি দিওঁ, তাৰ মানে b2 যদি আগত লিখো, এটো তাৰ পাছত b ত কি এলিমেন্ট আছে? a b c, ইয়াত 1 2 3. they are related. You can check a1 b2 a3. so ইয়াত domain কি আছে? This is the domain. So what it is? Domain of inverse relation. This is the range of the inverse relation. This is the domain of the inverse relation. This is the range of the inverse relation. Now let us see how they are related with this. dr, this is the domain 1 2 3 and they are 1 2 3. That means it is a range of the inverse relation. This is a range of this is ABC, and here also it is ABC. So how they are related? They are equal. So we say that this is domain of the inverse relation. So they are interchanged, we can say. Here domain of this relation is equal to the range of the inverse relation, and range of the relation is the domain of the inverse relation. Have you understood this? Then we have taken another topic. This is identity relation. Let us see what type of relation it is. Let us take a set A. The elements are suppose 1 2 3. Let us take another set, and the elements are suppose 1 2 3 again. Okay, here the elements are denoted by x, and here the elements are denoted by y. Interestingly, we find that they are equal. The elements are equal. Here some elements are equal, not all. Now those elements which are equal, let us note down. And we get a set of the equal elements. First component and second component, they are equal. First component, second component, they are equal. If we get such a relation, this type of relation is called identity relation. Okay, here let us take this only. A B C 1 2 3 1 2 3. Although their Cartesian product is very big, 3 3 is 9. There are 9 elements. 1 is related to 1, 2 is related to 3 is related to 3. What condition we have taken? They are equal. The elements are equal. So in this order pair, first component, second component are equal. First component, second component are equal. In the third element also, first component and second component are equal. Okay, so this type of relation is known as identity relation. This is represented by I. Sometimes we say A is related to A, because actually they are equal. Same elements we have considered in this example. Okay, I is a relation from A to A. Now here one more interesting fact we want to see. What is the domain of this relation? Domain of this relation 1 to 3. And what is the range? 1 to 3. So they are equal. Domain and range are exactly same when it is identity relation. In identity, always you should know that it is xy such that x belongs to A, y belongs to B, and x is equal to y. This is the condition. তার মানে ফার্স্ট কম্পোনেন্ট আর সেকেন্ড কম্পোনেন্ট সেম হবই লাগিব। আমি বেলেগ এটা সাপোজ ইন আইডেন্টিটি রিলেশন উই ক্যানট রাইট লাইক দিস। সাপোজ 1 1 লিখিলো, 2 2 লিখিলো, 3 3 লিখিলো, তাৰপাছত এটা আহি গ'ল 1 2, 1 আৰু 2 লিংক কৰিলো, ৰিলেট কৰিলো। This is not a identity relation because only for this, because here they are not equal. Okay, tar pasat aru eta relation lom 1 1 2 2. Again this is not an identity relation because a 3 3 equal as ami likhai nai. So all the elements which are equal we have to note down, we have to write, then only it becomes identity relation. Okay, after that dear students we have taken another topic. Actually this will be the last topic, constant relation. Eta duta set loilo ami, set A, set B. In this way we have taken two sets. In the set A the elements are 1 2 3 4, in the set B the elements are 1 7 and 13. Suppose we want to find how can we relate them in terms of the factors. This 1 is a factor of 1, this 1 is a factor of 2. Okay, 1 is a factor of these 3, this 1 is a factor of this 4. So here what we have seen, 1 1 2 1 3 1 4 1, we make a set, or this is the relation, that is all the elements are related with only particular element of set B, then that relation is called a constant relation. Eta element logot etu no hoye 1 7 logot hobo, 1 aku 1 logot hobo, 3 13 logot hobo, it is not like that. Eta element logot etu link hobo. So here the domain of this relation is, how can I write, 1 2 3 4 suppose here in this case, and the range of this relation keta thakibo etai. Okay, this is only one, it is singleton set always. So I hope you understood today's topic whatever we discuss. Okay, thank you students.